All right, to continue our discussion here on scalar multiples, I'd like to do one that gives you the initial and terminal point for a particular vector. Here they're asking us to find the vector 5tx. And what that means is we're going to have some vector from the point t to x, which we can find. We were given both t and x. But they're wanting us to say, well, look, that vector is not enough. We need 5 times its total force or total magnitude to work with here. So remember that scalar multiples, they only affect magnitude, not direction. And what I really like is that we're going to do this problem by just looking for component form. So that should make this a fairly quick problem if you remember the basics of just taking these 2 points and setting up your component form. So let's do that. Here we have negative 412. That would be something pretty high up and to the left compared to the other point because it's down at 4 but to the right some. So we would end up on the right here with the point 74. And I've cautioned in a previous video to make sure to just go ahead and jot down the letters beside these points. If you don't, it's not wrong, and the sketch isn't even necessary. If you're really grasping this concept, you could set up your component form pretty easily either way. But I like to draw the picture. I think it helps a lot of time visually. So it says tx. That means we're moving from t down to x. So our vector would be something like this. Again, a sketch, so don't judge. But all we need to do from here is say, well, look, it's clearly moving downward, and it's clearly moving to the right. We're moving from 12 down to 4, so it's a drop of 8, so it's minus 8 in the y direction. And we're going from a negative 4 all the way up to a positive 7. That's a total distance of moving 11 to the right, to the positive direction. And we're going to have to be careful to not accidentally write this down wrong. Every once in a while I see people write the negative 8 first, so they think when they come over here that they should write it first again. But remember that we always lead with x and follow with y. Now, I should illustrate as well that traditionally speaking, in almost everything you'll ever do in a math course, or in any field of mathematics, it seems that x tends to come first. And it's easy to remember because it's just alphabetical. So if you're ever unsure, default to x first and then y, and then if something's weird or wonky about the problem you're working with, adjust accordingly. But what we've done here is we've actually come up with tx. This is the vector tx. We don't know its magnitude. We don't know its direction. Or rather, we know the general direction, but we don't know the angle measure for the direction. It did not ask us for those things, so don't waste your time on it. Some people often will look at a problem and they'll just do everything they can think of to do to a problem, but focus on what it asked you to find. It said 5tx, and it says leave it in component form. So don't worry about magnitude, don't worry about direction. And if that's the case, I can stop rambling, because we have this. We're just going to multiply this by 5. 5tx would simply be 55 and negative 40. And there's nothing more to it. Remember that scalar multiples, all they do is they magnify everything in the problem. They magnify your x, they magnify your y, and that creates a resultant vector that in this case would be 5 times as large as our original vector.